Hi everyone and welcome. Today we're diving into the fundamentals of IT troubleshooting, a process that goes far beyond just fixing errors. Whether you're supporting a single user or managing enterprise systems, effective troubleshooting means understanding the cause, recognizing the symptoms, and addressing the consequences. In this presentation, I'll walk you through a proven methodology, highlight key decision-making strategies, and show how documentation and preventive measures play a critical role in long-term system stability. Let's get started. Troubleshooting begins with problem solving. Every issue has a cause, a symptom, and a consequence. For example, a faulty hard disk causes a blue screen error, which prevents the user from working. From a business perspective, resolving the impact, like giving the user a new workstation, is often more urgent than fixing the root cause. Not all problems carry the same weight. A single user disk failure is serious, but it doesn't outrank a data center outage. Prioritize based on scope and severity. Recurring issues may signal deeper problems in the environment or supply chain, so always look beyond the surface. Effective troubleshooting follows a structured model. CompTIA's methodology includes identifying the problem, forming a theory, testing it, implementing a solution, verifying functionality, and documenting everything. This framework ensures consistency, clarity, and accountability in support cases. Start by identifying the problem's impact and symptoms. Ask the user detailed questions about error messages, recent changes, and attempted fixes. This helps determine severity and narrows down what to investigate, whether it's hardware, software, or something else. Now that we've identified the symptoms, it's time to form a theory. Ask yourself, what's the most likely cause? Don't overlook the obvious. Sometimes the fix is simpler than it seems. The issue could be hardware, software, or even a network problem. Start with what makes the most sense, then test your theory. Now that we've formed a theory, it's time to test it. Does the evidence support our assumption, or do we need to revise it? Eliminate what's working to focus on what's not. If the issue still isn't clear, escalate to the next level of support. Narrow down the investigation until you isolate the root cause, and polish your process for next time. Build a plan of action. Consider time, resources, and system-wide effects. For example, a software patch might fix one issue but break another. Always follow corporate policies and get proper authorization before making changes. Before making any changes, always check the backup status. If no backup exists, perform one immediately. Protecting user data is critical. Once the backup is confirmed, implement the solution based on your tested theory. This could mean restarting a service, reinstalling software, replacing hardware, or adjusting network settings. Apply the fix carefully and monitor the system to ensure the issue is resolved. Once the solution is applied, verify that the original problem is fully resolved. Test the system to ensure everything is functioning as expected. Then document your findings, what the issue was, what actions you took, the outcome, and any lessons learned. Clear, concise notes help future troubleshooting and build a reliable knowledge base. They also highlight the value of support work, especially when third-party providers are involved. Write professionally, others will depend on your documentation. To prevent future issues, implement proactive measures once the system is stable. Check building power after a blown fuse to avoid electrical disruptions. Ensure antivirus software updates automatically to protect against new threats. Train users to recognize warning signs and follow best practices. Update tools and systems regularly to maintain compatibility and security. These steps strengthen your environment and reduce the risk of recurrence.